I'll say today in lab, this is a pre-test. We have 40 samples, we have 10 minerals, 10 igneous rocks, 10 sedimentary rocks, and 10 metamorphic rocks. So I'm going to go through and give a sample of each. So I'm here on campus today by way of a bicycle. Nobody's in the lab here but me and my trusty video camera. So I'm going to go through and we're going to start with the minerals first. So the first 10 samples will be minerals. I'm going to give a brief description of each mineral. So starting with number 1. This is a non-metallic mineral, very black in color. It has 6120 cleavage. It leaves a slight greenish black streak. And it has kind of a wood to fibrous look to it. Mineral number 2. This variety of this mineral is almost crystalline. Has a hardness of 7. It's non-metallic. It's going to be on chart number 4. And so the hardness should give it away. It's a rock-forming mineral and very important. Moving to number 3, another rock-forming mineral. This appears in granites as a phenocryst. It has good cleavage, 90-degree cleavage in 2 directions. This mineral, this particular sample is pink. This mineral can be white and even a green color. The green one is always referred to as microcline. But we don't call this a microcline because it's not green, it's pink. So remember, this mineral can be pink or white, forms phenocryst, good cleavage. It has growth lines in it, but they're not striations. So don't refer to this mineral as having striations. Mineral number 4 has really good cleavage, and you can see the vitreous luster on the cleaved parts. This mineral can be many, many colors. It will not scratch glass. Hardness around a 4. Good cleavage. Often forms octahedrons. Multiple directions of cleavage on this mineral. Number 5. This mineral reacts to hydrochloric acid. So as soon as you put acid on it, instantaneous reaction to it. It has 6120 cleavage, and that's kind of apparent here. Good cleavage on 3 different sides. Reacts instantly to hydrochloric acid. Softness around a 3 on the hardness scale. Number 6. This mineral is cubic. Almost translucent. Has very good cleavage in 3 different directions. So it has excellent cleavage. Vitreous luster. And it has a salty taste. Number 7. This mineral can be listed as a metallic mineral and a non-metallic mineral. It depends on its state of decomposition. The diagnostic feature, the thing that gives this particular mineral away, is it has a red-brown streak. So it's kind of a dull luster. It's an iron-rich mineral. No cleavage, fairly high specific gravity. It's a pretty heavy mineral. Does consist of a lot of iron. And the diagnostic feature on this particular mineral is that it has a red-brown streak. Moving on to number 8, another important rock-forming mineral. The diagnostic feature about this mineral are those lines. These are straight lines. These are striations. This mineral has a bluish green tint to it often, a play of colors. Cleavage on one side, cleavage where the striations occur. And this is excellent striations on it. So you can actually see those lines, those striations. Number 9, of all the minerals, this is the most heaviest mineral, most dense. This has the highest specific gravity of any mineral. This mineral does have cleavage. It actually forms cubes. There's a white mineral intermixed with this, which is calcite, and don't worry about that. We're looking at this gray mineral. You can see in some parts where it's cleaved, it has a nice vitreous luster, a silver shine look to it. The highest specific gravity of any mineral that we have. Very heavy. And then the last of the minerals, number 10. This does not have cleavage. It's massive. Random break. Very rich in iron. And the diagnostic feature about this particular mineral, both these pieces, are magnetic. So magnet will stick to both of these minerals. So this mineral is magnetic. All right, igneous rocks. So we now move over to the igneous rocks, and I'm going to basically tell you felsic, mafic, what's in it, and a little bit about the texture. So this is rock number 11. It has 2 basic minerals in it. It has white plagioclase and black amphibole. This is 50-50, so this is intermediate. This is phaneritic. You can actually see the minerals in it. So visible minerals to the unaided eye. Intermediate. Phaneritic texture. Number 12. This texture is obvious. It's glassy. Very random break of this mineral. So this was called conchoidal fracture. The mineral composition of this rock is basically quartz. Its metamorphic composition is felsic. Even though it's dark in color, most of this rock is quartz. A little bit of iron got in there to turn it dark. Number 12. Number 13. This rock is felsic. Its texture is aphanitic, no visible minerals, and it's felsic. The pink color in this rock is due to an abundance of potassium feldspar, K-spar. So aphanitic, no visible minerals, and felsic, very felsic. Let's move on to number 14. 14 is going to be mafic. So 14 is a mafic rock. Its texture is phaneritic, so it has visible minerals in it. All these minerals are dark, so it's really hard to distinguish between the different minerals. So this has minerals in it like amphibole, the very dark plagioclase. And because those minerals are all dark, it's really difficult to make a distinction, but this texture is phaneritic, and this rock is mafic. Another mafic rock is number 15. However, the texture on this is porphyritic. And the reason it's porphyritic is the background is really aphanitic, but it has these larger minerals. These are amphibole minerals that are sticking out. So it is porphyritic, and its composition is mafic. Number 16. This is pyroclastic, made from fire. This is the ejectile material out of a volcano. So you see fragments of rocks in here. You see very fine-grained ash. So again, texture is pyroclastic, and it's felsic. Very felsic, very light. Okay, rocks number 17, 18, and 19 I put together for a reason. All three of these rocks are going to be felsic. What's going to differ about those is the texture. So this mineral, this rock here, has very large minerals. It has big pieces of quartz and large fragments of muscovite. So this texture is pegmatite. So pegmatitic is the texture. The composition is felsic, so it's quartz rich. It's very rich in quartz. Big old pieces of quartz in this rock and very large pieces of the muscovite. Number 18. This has one large mineral that kind of stands out, and that's this pink mineral here, which is potassium feldspar. It also has some biotite in here and some quartz. So the composition is going to be felsic. The texture, however, is going to be porphyritic. And the porphyritic part of it is that the phenocryst, the larger mineral that stands out, is the big pieces of potassium feldspar. The K spar sticks right out in this mineral, in this rock. And then number 19, also a felsic rock. This rock has a phaneritic texture. Even though it's very fine grain, it is phaneritic, so you can actually see the individual minerals in this rock. So it's felsic, phaneritic texture. And the last igneous rock is number 20. And we're going to concentrate on the green material here. So if this was a mineral, we would call it olivine, but this is not a mineral. This is actually a rock. So this is ultramafic. The ultramafic rocks tend to be green in color. And so this green part here we're concentrating on. And so this is phaneritic texture. Often this kind of borders on aphanitic, but this is actually phaneritic. Visible minerals. Ultramafic. And that ends the igneous rocks. Moving on to number 21, sedimentary rocks now. So all these yellow rocks, yellow area, are all going to be the sedimentary rocks. So number 21, this is a clastic rock. Its grain size is sand. So it's a clastic or detrital rock. Its grain size is sand. It's going to be on the first chart of the sedimentary. And because it has a red color, we have to name it for the red color. So the red color is really important. It's an important aspect in the naming of this rock. So don't forget the red color. And this is going to be on chart number 1. So that's number 21. Moving on to number 22. 22 is also a clastic rock, clastic or detrital. This rock grain size is going to consist of clay minerals. And you can see a layering of this rock. This rock is very well layered. It's what's known as fissile bedding. This texture is going to be important if this rock ever becomes metamorphosed, because it's going to form a foliated metamorphic rock. So this is clay-sized material. The sample before that, number 21, sand-sized. So you can actually see the sand grains in this, where it's really hard to see the clay minerals in this rock. But you can definitely see a layering to this rock. So that's number 22. Moving on to 23 and 24. I put these together. So they both react to hydrochloric acid. So you know they both consist of carbonate. They consist of calcite. They're going to be, both of these are going to be chemical rocks. So both of these are chemical. 21 and 22 were both classic rocks. So these are rocks were formed in a water-rich environment, chemical. This rock here its main composition is calcite and broken up seashells that have been all kind of glued back together. So this is all basically seashells, all glued back together. So that's number 23. And then 24 also reacts to acid, another chemical rock. This rock, when you put acid on it, it effervesces immediately. This rock is full of fossils. Those little round things are called crinoids. This other sample here has the head of a trilobite. There's the fossil. So this is definitely has fossils in it. And the word fossil is going to be a major part of the naming of this rock. So that's number 24. Number 25 of sedimentary rocks is this. So there are three varieties of this. This happens to be the red variety. Its chemical composition is quartz, hardness of 7. This is a chemical rock again. This is what makes up petrified wood. So I don't want you to name it as petrified wood. I want you to name it as the sedimentary rock. And there's three varieties of this. The different varieties are named according to color, and the main color of this one is red. So pay attention to the red color. Number 26, we go back to the clastic rocks again. And this is a classic rock. It's going to be on chart number 1. The grain size is going to be sand. However, what makes this rock a little bit more unique, what makes it stand out, is it has sand and clay, but it also has larger fragments of potassium feldspar in it. So because it has large fragments of K-spar in there, we give this sand-sized rock a unique name. So look for a sand-sized rock that has poorly sorted, this is very poorly sorted, and it has large fragments of potassium feldspar in it. So that's number 26. Number 27. A classic rock. The grain size is going to be gravel. And so what you have to be careful about the gravel size rocks is you have to look, is the gravel rounded or is it angular? Rounded or angular? So that's the things you need to look for this particular rock. Classic gravel size rock, chart number 1. Now switching back to chemical rocks again. This rock's main chemical composition is organic carbon. This is a biochemical rock. It is layered. It is soft. It will burn. It's fairly soft. Comes in layers and burns. Number 29, back to the clastic rocks. So number 29. This is a classic rock. It's going to be chart number 1. Its grain size is gravel. And it's very similar to 27, except for the grain size differs. And I have to go over and turn on the lights. The lights in this building. I'm moving around in here, but they don't recognize me moving around. So I got to go over and hit the light switch. There it goes. Guess I'm not moving fast enough. Energy saving lights, right? Even though I'm here, they'll turn on the lights off on me. All right, sorry about that. Number 30. Yeah, this is all part of doing Zoom labs, right? For the year 2021, at least the vaccine's out and the numbers are going down. That's good. So number 30, this rock is a chemical rock. It reacts to hydrochloric acid. But it reacts to hydrochloric acid very slowly. So when you scratch the surface on this rock, it reacts to hydrochloric acid very slowly. So unlike limestone, when you put acid on limestone, it instantly reacts. This rock has a very, very slow reaction to hydrochloric acid, but it does react, but very slowly. And its chemical composition is calcium magnesium carbonate. That's what sets it apart from limestone. So that's number 30. So that ends the sedimentary rocks. And now we just have a few rocks left. We'll go to the metamorphics. And I put this in a particular order. Did the same thing when I did lab, by the way. So I put this in order. So pay attention for the first four. This follows the metamorphic grade, so this should help everybody out. All right, this rock here, number 31. Dull texture. This is a foliated rock. So remember, in metamorphic rocks, there's two textures. There's foliated and non-foliated. And where we get the foliation on this rock is it has a layering to it. So you can actually see a layering to it. Might be hard to see with this crazy camera. But this is dull, no visible minerals. This is low-grade metamorphism. This is a foliated rock, red color. Number 32, the next degree of metamorphism. This is very similar to 31. Again, layering to it. But instead of a dull texture, this has a slight shine to it. So you can actually see a shine to this, in comparison to 31, which is dull. This one actually has a little bit more of a vitreous luster to it. And that's because the minerals quartz and muscovite are coming out. 33, also foliated, but what's interesting about number 33 is this rock actually has visible minerals. This is full of mica. So lots of micas in this. Both muscovite and biotite, giving it this vitreous luster. So this is foliated, visible minerals. The metamorphic composition of this rock is micas, muscovite, biotite. And there are actually some little teeny garnets in here, but God, you really can't see them that well. The garnets just aren't showing up in the camera, but I can see them with my eye. That's kind of strange. So I have better sight than this camera does. But there are little teeny garnets in here. And that's one of the diagnostic features of that rock. Highest grade of metamorphism for the foliated rocks right here, number 34. This rock has a layer to it, a banding to it. So basically, this is the highest degree of metamorphism. The black mineral is amphibole, and the white mineral is plagioclase. They make these nice little layers to them, banding, and it's the highest degree of metamorphism. So 31, 32, 33, and 34 follow the metamorphic grade. Number 35 is non-foliated. It is comprised of almost pure carbon. This too will burn. Non-foliated rock. 36, we go back in the foliation. This is the schistose phase of foliation. So this type of foliation is schistosity. And it is a black rock. And the main mineral in this is amphibole. So this rock is comprised entirely of the mineral amphibole. Just a bunch of teeny tiny little microscopic amphibole minerals. It does have foliation to it. It does have a layering to it. Very black color. The parent of this rock was either a gabbro or a basalt. Moving on to number 37. Again, a foliated rock. Green color. May be difficult to see the green color in the light in this room. But this rock does have foliation, has a layering to it. Has a green color due to chlorite. And so because this rock is green, we have to name it according to the green color. So it does have the foliation of a schist, but because it's green, we give it a special name. All right, number 38 and 39 look a lot alike. And I'll actually slide these together so we can get a better perspective on the two. So 38 is a very hard rock. Its metamorphic composition is quartz. So it's made out of quartz. It will scratch glass. It does not react to hydrochloric acid. Its neighbor is non-foliated, but it has a very coarse-grained texture to it, and those coarse crystals that you see in there are calcite minerals. This does react to hydrochloric acid, and it will not scratch glass. It's much softer. Its parent was a limestone. Number 40, the parent of this rock was either a conglomerate or a breccia. So it's easy to find the name for this rock. Just put the meta on top of it, and you'll have what the name of this rock is. So its metamorphic composition is rock fragments and quartz fused together. Like I said, it was either a conglomerate or a breccia, and this is the metamorphic rock. So this ends metamorphic rocks, and this ends the pretest. And so good luck. Go through your charts, go through your old labs. Everything I've given you, we've had in lab, so I wouldn't give you anything that we have not had in lab. So go on the Canvas. Anything that you get correct on this is extra credit. The test next week will be laid out pretty much the same format. I may switch things around a little bit, bring in some different samples, but the format will be identical. You'll see 10 minerals. You'll see 10 igneous rocks, 10 sedimentary rocks, and then 10 metamorphic rocks for a total of 40. And so now I will tell the answers in the next video.